Hello everyone. We are back now to talk a little bit about neural nets, and we are going to use code to facilitate the understanding. Who for those are not familiar with, let's say, neural nets. Okay, we are not talking about convolution neural nets yet. So on this session, it's only about neural nets. As you can see, we are breaking down different concepts for later put all together. Okay, and this one, we are gonna build a neural net from scratch, and you're gonna be looking each step of a neural net, and we are gonna try to bring some practice on all the, let's say, concept that you see in the internet, and that only make things harder. Okay, so the first thing that you're gonna be looking at, it is a neural net, which you're gonna be using backpropagation algorithm, and that's basically the main algorithm used on neural nets. And why it's called backpropagation is because this architecture basically go forward, and then based on the loss based on the distance between the prediction and the real value, would be backpropagated and be updating every layer, every neuron on our architecture. Okay, so basically when you talk about neural net, we have basically two steps. One, it is to build our architecture, right? Neural net architecture. And the second one, it is be able to calculate the loss for the predictions that it is that our model it's let's say outputting. Okay, so basically when you're talking about neural nets, we have input layer, and then you have many hidden layers. In our case here we have only two, and for each hidden layer we are gonna have weights which will be used to calculate against the inputs, and the result of every neuron on every layer would be used for the subsequent layer and neuron until it get to the end. So basically here, every item here, it is a neuron, and this is a layer. Okay, on the number one, it's a layer, but it's input layer, and the number two, it's a hidden layer, and here will be the second hidden layer, and here the output layer. Okay, and we're gonna see that in the code. It would make more sense, but it's basically, I want you guys to understand that we have input layer here, which will be our matrix, and then we'll be calculating against some weights, and based on this calculation we are gonna see in the end how far it is from the expected value. For example, if I input an image with label cat, based on those calculations that's gonna have on each layer, this should be output cat, and if it's not cat, we need to see how far it is from cat. Okay, and then we backpropagated the distance from the right answer back, and each neuron will generate new weights based on the distance from the right answer. Okay, and weights, basically it is what it's basically the result of learning. So every time that we are learning, we are calculating better weights for our equation. Okay, I think look, we can move forward to the code, and you can look back. Maybe we'll look back on the image again with more context. So basically, there is some important concept that we're gonna be looking in separated, as we always do. It is like the calculation that happens on neural net. It's basically a bunch of dot product, and dot product it's basically a calculation between two vectors, which will tell us how similar it is two vectors. And you're gonna see, for example, in this case here, I don't know if you guys remember how dot calculation works, but I didn't remember. So just a quick recap here. So we have 1, 2, 3 vectors, and you want to be calculating those here. So how you calculate the dot? It is basically calculating a vector with another times another vector, and then we give the plus both vector. This is basically dot. Super simple, right? And this is the very simple way. And when you do this calculation, you will see the difference between two vectors, and basically would be the distance that we were talking here. That's how we're gonna see the distance between what was the expected answer and the let's say predicted answer from our model. So for example here, first we do that very simple one using Python, and then we use the same calculation but with NumPy, and you can see that NumPy just give dot and give the two vectors, and we will to put our the answer that we need. So basically on this case here, the product 2, it is closer to our vector. So for example, this vector, it is closer to this vector in the result, as you can see, right? So it's kind of closer, and this one is further based on the result of the product. So the first product is this one, and the second product is this one. So you can see that this is closer because it's higher. Okay. So this is very simple concept, dot calculation, to see the distance between two vectors. You're gonna do that all the time on our neural net. Another thing that we use a lot is matrix multiplication, right? And you're gonna see in another perspective here, which you have two matrix, right? Now it's not a simple vector anymore, but instead two matrix, and you're gonna build our very simple neural net here just to exemplify these two calculation. And you can see that basically we have two lines of in our two rows in our matrix and two columns. Okay, so each row, it is a layer, and which column, it is one neurons. So for example here, we are gonna go through each layer, see two layers in our case, and you'll be doing some math calculation, very simple one. So here we have the inputs. Let's remember that we have inputs and two hidden layers. We are doing the same here. Two hidden layers and one input. Okay, and then we are going through each input. Basically, the input, it is every line hits one input. When you talk about convolution, every line would be one image. Okay, but this here we are simplifying as much as possible. So every line here, it is one input, which will be used again with those layers. So we start passing the input, and you pass the two hidden layers values. So hidden layer with weights, and remember even each one here has a weight, which will be used to calculate the used to learn. So, and basically you will pass this weight, and you can see the results of the calculation, and then after having this result, we would see how far this result it is from the expected result, and based on this difference that you get from function loss, would backpropagate and change those weights to for something that would give a better result. Okay, so on this part I just wanted to show that you pass some weights, so our neural net would be generating randomically a sort of random weights, and based on the function loss we will change those weights and try it again, and trying to predict again. So that's backpropagation. Let's say give an input, we will calculate on the weights and come with an answer. Then you look at the answer to see how far it is from the expected result. Then you go back and change the weights and do everything again and calculate again. That's the process of backpropagation. That's the whole concept on the deep learning. It's basically that. That's it. It's as simple as that. You're gonna see more details that you have in neural net, but it's basically that. You're gonna see that everything boils down to this simple calculation of weights and trying to predict and see how far we are from the right answer, going back and adjust the weights. That's the process of learning. Change those weights, it's you learning something. We are gonna break down this this lesson and other, so I'll pause it here and we'll come back to continue with the following concepts.